Welcome, dear students, to Physics Virtual Lab, Delhi Public School, Bangalore East, Grade 12. Continuing with the series, we will conduct another experiment using the meter bridge.
Experiment 1.1. Aim to verify the law of combination of resistors in series using a meter bridge. Apparatus: meter bridge, battery eliminator, galvanometer, resistance box, jockey, plug key, resistance wire, meter scale, connecting wires, two resistors R1 and R2. Theory: using the principle of Wheatstone bridge, in balance condition, R over P is equal to X over Q. Rearranging, X is equal to QR over P. In the meter bridge, we have the resistors P and Q in the form of the wire. Therefore, P is equal to rho L over A and Q is equal to rho 100 minus L over A, where rho is the resistivity, L is the balance length and A is the area of cross section of wire. X is equal to 100 minus L into R over L, where R is the known resistance and L is the balance length. In this experiment, the unknown resistance is the effective resistors in series RS, which is equal to R1 plus R2. We will analyze the circuit with the circuit diagram and the components of the apparatus. We have the battery here. This is the battery. Plus is the red terminal and the negative is the black terminal. Then you have the point A here on the meter bridge. This is junction A on the meter bridge. Then you have junction C. So this is C on the meter bridge. This is the meter bridge wire here, which runs from A to C. Then this is connected to the across these two terminals you have R1 and R2. These are the unknown resistors in series, R1 plus R2. That is the aim of the experiment. We need to determine R1 plus R2. Then this is the junction B. So this is B here. This is connected to the galvanometer. So we need to connect to the galvanometer, one of the terminals of the galvanometer. You could interchange the terminals of the galvanometer, just the deflection direction changes. And then the other terminal of the galvanometer, we need to connect it to the jockey. This is the jockey. We need to connect it to the jockey, which will slide down the wire, dividing it into P and Q resistances. Then we move on to the other junction here. Across these two points or junction, we have the resistance R. This is the known resistance box R. So whatever key we are going to unplug, that resistance will be included. In case if I am going to unplug this, then 1 ohm is included in the circuit. Then from C, of course, we go to the plug key. This is the key and which is going to make or break the circuit, and from the other terminal of the key, negative to the battery. So we will actually make the circuit connections now. So from the terminals of the battery, we have the plus terminal and the minus terminal. So I am connecting wires to the plus. And from plus we see here that it is going to junction A. So this wire is short. I am going to extend the wire and I am going to connect it to junction A here. This is A. Then we move on to this. From A, you have this resistance R which is connected. So this is the resistance R which is connected across these two terminals of the meter bridge. Connecting across these two terminals. Then you have the B junction here, the B junction here, which goes to the galvanometer. So junction, one end of the galvanometer, then the other end of the galvanometer goes to the jockey. Again, jockey needs a long wire, so I'm going to connect it with another wire like this, and this is the jockey. I can remove the jockey, so here I've made the connection to the jockey, and I will connect it back. Then we move on to this terminal. Here, these two terminals across which the resistors are connected. So we will take one resistance by one resistance. We will have to first find what is R1, what is R2, and then what is R1 plus R2. So I just connect one of the resistors here, R1, only R1 I am connecting. So this is only R1. I'm going to remove my unwanted wires. This is also not connected. Then we have reached here, so we will go to terminal C. So this is terminal C to plug key. So we will take a wire from terminal C. So this is terminal C, and it goes to the plug key, one end of the plug key, and the other end of the plug key will go to the negative of the battery. So here it is. It goes to we follow this wire, it goes to the negative of the battery. So the circuit is ready now, and it's ready to take the resistance of R1 first, so R1, and then we will find individually what is R2, and then the combined resistance in series. We start with trial 1 for R1. Put on the battery. Ensure that the plug key is closed. We are removing 1 ohm. So 1 ohm is included. R, capital R is equal to 1 ohm. Capital R for trial 1 is equal to 1 ohm. Please note that down. Next we check for opposite deflection. We hold the jockey at A. Notice the galvanometer shows deflection to the left. Next, we take the jockey to C. And note the deflection is to the right. We find the balance length. As we move on the wire, we see that it's deflecting still to the left. We need to get zero deflection, yes. Now there is zero deflection in the galvanometer. Galvanometer is showing zero deflection. And we take the corresponding length, balance length. You need to take the top scale. So the top scale is showing, giving you the reading. You need to note the reading and post it in the chat box. Trial 2 for R1. Put on the battery. Ensure that the plug key is closed. Capital R is equal to 2 ohm. We need to set 2 ohm for capital R. We'll check for opposite deflection as before. At A, it is to the left, and at C, it is to the right. We take the balance length for trial 2. It is deflecting to the left. We have to get 0 deflection. I'm moving it on the wire till I get 0 deflection. Yes, this is 0 on the galvanometer. So I need to take the reading. So place the scale, remove the jockey, and you can take the reading and post it in the chat box. Take the reading and post it in the chat box. Take the top scale reading and post it in the chat box. Trial 3 for R1, we put on the battery. Then ensure that the plug key is closed. We have to unplug 3 ohms. So capital R is equal to 3 ohm. Note that. Next, opposite deflection. At A, it is to the left, and at C, it is to the right. Next, balance length. I keep sliding on the wire till I get balance length equal to, let's approach 0, yes, 0, and we take the balance length on the meter scale. I remove the jockey, I place the scale here, remove the jockey. Please take the readings and post it in the chat box. Top scale readings in the chat box. Post the top scale readings in the chat box. Now we will be determining the resistance for resistor R2. So we are going to connect R2 in the circuit and remove the R1. So this is R2. So trial 1 for R2. Trial 1 for R2, we put on the battery, ensure that the key is closed, and capital R equal to 1 ohm. Capital R equal to 1 ohm. Capital R equal to 1 ohm. Check for opposite deflection. At point A, you have the deflection to the left. At point C, when the jockey is placed at C, you have deflection to the right. We'll find the balance length. Yes, the balance, we've got 0 on the galvanometer. And the balance length is yes. Take the top scale. Post your readings in the chat box. Trial 2 for R2. Put on the battery. Ensure that the key is closed. Capital R is equal to 2 ohms, so we need to set capital R at 2 ohm. Check for opposite deflection. Jockey at A, deflecting to the left. Jockey at C, deflecting to the right. Balance length, so it's going on deflecting to the left. I'm moving the jockey on the wire, and we will see where we are going to get the balance length. Yes, it's here. galvanometer is showing 0 and the meter bridge, the reading for L. I'll be removing the jockey and you can take down the reading from the meter scale. The top scale, it is, you can post your readings in the chat box. Trial 3 for R2. Put on the battery. Ensure that the key is closed. Capital R, we have to set it at 3. So, capital R is at 3. 2 plus 1, 3. Check for opposite deflection when the jockey is placed at A. It's deflecting to the left. Jockey moved to C. Deflection to the right. Next, the balance length. Slide the jockey on the meter scale or on the wire, till you get 0 deflection. Yes, it is 0 on the galvanometer. And we need to take the length on the meter scale, the top scale again. You can check the reading here. On the top scale, post the readings in the chat box.
Trial 1 for RS. Right now we have only 2 ohm resistance here. We need to make the series connection for R1 as well as R2. So I am placing R1 and R2. So this is the series connection for R1 and R2. Okay, one end over here it goes to this point and the other end to one more resistor, and these two are connected in series. We move on with the trial. We have to switch on the battery. Ensure that the plug key is closed. 2 ohm resistor is removed for R. So capital R is equal to 2 ohm. Check for opposite deflection. I am placing the jockey at A and the galvanometer is deflected to the left. When I place the jockey at C, the galvanometer is deflecting to the right. I slide the jockey on the wire to find the balance length. Galvanometer reads 0. And the corresponding balance length you can take the top scale reading and post it in the chat box. Trial 2 for RS. We put on the battery. We unplug 3 ohms from the resistance box for capital R. We take the balance length. Yes, the galvanometer reads 0. We place the scale and you can take the reading from the top scale. Post it in the chat box. Trial 3 for RS. Same procedure. Put on the battery. We unplug 4 ohm from the resistance blocks. 4 ohm for capital R. And take the balance length. Sliding the jockey
the galvanometer reads 0 and the corresponding balance length. Take the scale and take the top scale and post your readings in the chat box. Check your observations and calculations. Result within the limits of experimental errors. Theoretical and experimental values of RS are same. Hence, law of resistance in series was verified. With this, we have come to the end of the session. A gentle reminder, note down the date, work on simulators, complete your record. Stay safe, stay connected. Thank you.